modern lightweight diesel engine has become an accepted part of the motoring scene. It's efficient and economical, particularly around town. The image of slow, smelly and noisy diesels associated with the older and poorly maintained commercial vehicles has all but disappeared. High revving and quieter running diesels are now an established part of the passenger car market. Environmentally, the diesel has also become more acceptable, as a correctly maintained diesel engine can produce less carbon monoxide and less unburnt hydrocarbons than a catalyst-equipped petrol engine. Recent developments by Volkswagen have seen the introduction of an even cleaner diesel engine, known as the Umwelt diesel. Umwelt is the German word for environment, and this new engine has been specifically designed to produce lower exhaust emissions. Compared with conventional, naturally aspirated and turbocharged engines, it provides a further reduction in the emission of carbon monoxide, nitrogen oxides, particulates, commonly known as soot, and the unpleasant smells with which we are all familiar. Furthermore, this engine, which is also fitted with a catalyst, is distinctly quieter than its predecessors. But to start with, let's take a look at the basic differences between the diesel and the petrol engine and find out why the diesel is so efficient. As you know, in the petrol engine, a mixture of fuel and air is compressed by the piston, which is then ignited by the spark plug. This burning mixture expands and pushes the piston down on its power stroke. The engine's overall power output is controlled by the throttle valve. At full throttle, the cylinders are filled with an air-fuel mixture, allowing the engine to develop full power. However, in part load situations, the throttle valve is used to limit the quantity of mixture flowing into the cylinders, and consequently, the engine's output is lowered. Unfortunately, this throttling of the intake to reduce the mixture allowed into the cylinders also has the effect of reducing the compression pressures and, in turn, the engine's efficiency. In the diesel engine, only air flows into the cylinders. The air is compressed into a much smaller space than that of the petrol engine. A compression ratio of 23:1 is quite common for a diesel engine, in comparison with, say, 9:1 for a petrol engine. By compressing the air so much, it becomes very hot. At this point, a fine mist of diesel fuel is injected into the air from the injector. The fuel is then ignited by the hot air and consequently burns. The expanding gases force the piston down on its power stroke. In the indirect injection diesel, as fitted to many of the Volkswagen Audi range of vehicles, the fuel is injected into a separate chamber known as the swirl chamber. The chamber is designed to cause the air to circulate as the piston rises on the compression stroke, so improving the mixing and burning process as the fuel is injected. When the diesel engine is under part load situations, only the quantity of fuel injected is reduced, and not the air. Unlike the petrol engine, this enables the compression pressures to be maintained, and therefore the engine's efficiency. So, to recap, In the diesel engine, the engine's output is controlled only by varying the quantity of fuel injected, and not by restricting the airflow. To ensure reliable and quick cold starting, a glow plug is fitted to each swirl chamber. These plugs, which are controlled by an electronic relay, glow red hot for a predetermined period of time when the ignition is switched on. This pre-warms the air in the swirl chambers and ensures good ignition of the fuel. Once the dash warning light has gone out, the engine can be started. The period of time during which the plugs and warning light are lit is dependent on the coolant temperature. As the engine is cranked, the glow plugs are automatically switched on again, and they remain lit for a few seconds after the engine has started to reduce exhaust smoke. At normal operating temperature, the glow plugs are not required, so the engine can be started immediately. On some more recent models, a more sophisticated system known as extended glow period is fitted. It comprises an electronic control unit and a relay with a combined resistor pack and fusible link. In this system, the glow plugs remain lit at a slightly reduced voltage for an extended period of time after the initial startup. This helps to further reduce noise, exhaust emissions, and improve the idle. Another starting aid is this cold start lever, which should be pulled out before starting a cold engine. This also helps to reduce emissions by slightly advancing the point of injection at low engine revs. The lever should be pushed in once the engine is warm. Fuel is drawn from the tank via the main filter assembly by a self-bleeding vane-type lift pump, which is an integral component of the rotary injector pump. A drain tap, on the bottom of the filter, is provided to drain off periodically any water that may collect in the system. From the internal lift pump, the fuel enters the high-pressure element of the injector pump. Simplified, here the fuel is both distributed in the firing order to each of the injector outlets and pressurized to a very high pressure. This high pressure, which builds up in each injector pipe in turn, is determined by a spring within the injector. The spring holds down the injector needle, keeping it firmly on its tapered seat. Once the spring pressure is overcome by the fuel pressure acting on the needle lifts and chatters. Due to this action and the design of the needle and nozzle assembly, a fine cone-shaped atomized spray is produced. This is essential for good ignition. The quantity of fuel sprayed, or more correctly injected, is determined by both the position of the throttle lever and the governor mechanism within the injector pump. When the injector needle closes, any excess fuel is returned via the return lines back to the tank. It also joins fuel returning from the injector pump. On later vehicles, this return line fuel, which has been warmed by passing through the injector pump and system, is recirculated through the filter assembly. This helps to prevent the fuel waxing in freezing weather conditions. A thermo valve switches off this short-circuit recirculation through the filter when the fuel temperature rises above a predetermined figure. Return fuel then flows directly back to the tank. When the ignition is switched off, an electromagnetic cut-off valve mounted on the injector pump interrupts the fuel supply, thereby stopping the engine. For the purpose of this program, we use two 1.6-litre engines, one fitted to a Volkswagen Jetta and one from a Passat vehicle. However, the basic procedures demonstrated are similar for all diesel engines up to 1.9 litres. Before starting any repair work, here are a couple of points to remember. Preliminary help with engine fault diagnosis can usually be found in the relevant sections of the fault-finding manuals. And, as diesel fuel can cause skin problems, for your own health and safety, make sure you always wear protective gloves or use a barrier cream before starting work. For the engine to work efficiently, it's essential that there are no air leaks within the fuel system. If an air leak is suspected, then the system can be checked quite simply by using the cooling system tester and adapters. Remove the return line from the injector pump. And connect the tester. By the way, be careful never to exchange accidentally the return line union with that of the supply, as the return union has only a very small restriction drilling. Using a clamp, close off the fuel supply line near the tank. And build up a pressure of about 1 bar. The injector pump and supply line are now pressurized and can be checked for leaks. You may have to pump up the system several times at first to expel any air. If the pressure continuously drops, then systematically reposition the clamp along the supply line until the leak area is localized. One particular area to check for leaks on later models is the rubber O-ring on the thermo valve of the fuel filter assembly. Incidentally, the fuel return line can be checked in a similar way by connecting the tester to the fuel supply connection. Other than the fuel injection system, the engine's construction is basically the same as that of the petrol models. So let's look at the most important areas to be aware of when working on the diesel engines. As we already know, high compression is a prerequisite for a diesel engine's operation. Therefore, it makes sense, if you're in any doubt about the engine's condition, to start your diagnosis work by checking the compressions. Before starting, here are 1 or 2 points to note. Firstly, make sure the engine is warm. And remember, when working on the fuel system, absolute cleanliness is essential, as any dirt entering the system can damage the components. So before removing the injectors, start by cleaning the pipes. To avoid stressing the pipes, always remove them as an assembly and never individually. And to prevent fuel from being pumped out over the engine while cranking it, disconnect the fuel cut-off valve. Remove all the injectors and also the heat shields. This avoids the possibility of the heat shields being blown out into your face while the engine is turning over. However, to ensure a good seal when fitting the compression gauge, always fit a heat shield between the compression tester adapter and the cylinder head. Using the appropriate gauge, check the compressions in the normal way and compare them with the values in the repair manual. If a low compression is recorded, then it's advisable to carry out a cylinder leakage test to localize the fault area. While the injectors are out, it's also a good opportunity to check the operation of the glow plugs. Firstly, remove the wire from the temperature sender. This makes sure the glow plug system will operate irrespective of the coolant temperature. Switch on the ignition for a maximum of 15 seconds and check the glow plugs. If only one glow plug fails to light, then it will probably just be a case of replacing the individual plug. But if none of the glow plugs are working, then a thorough check of the wiring, fusible link and relay will need to be made in conjunction with the current flow diagram. If you notice a glow plug with a burnt end, then it's almost certain that the accompanying injector is faulty, and it will need to be tested. If the injector is not repaired, then serious and expensive damage to the piston and combustion chamber can occur. By the way, the heat shields, which protect the end of the injector and form a gas-tight seal between the injector and cylinder head, are compressible. So when refitting the injectors, always fit new shields and make sure they're installed in the correct direction. An alternative electrical method of checking the glow plugs, which does not require the removal of the injectors, is described in the repair manual. With this method, the total current consumption of the glow plugs is measured using the current clamp of the VAG 1315A or an equivalent tester. By comparing the amperage reading with the chart in the manual, an indication of the number of glow plugs that are working can be determined. The first signs of injector problems can usually be recognized by misfiring, engine knocking, loss of power, exhaust smoke, or increased fuel consumption. Initially, a faulty injector can often be located by running the engine at a fast idle speed and slackening each injector pipe union in turn. If the engine speed remains constant, or the smoke or knocking disappears, then it's probably that particular injector which is at fault. Once removed, the injector can firstly be visibly examined and then checked with the injector tester. When testing an injector, ensure the nozzle and spray area is suitably shielded, and never place your hands anywhere near the injector spray, as the high fuel pressure can penetrate the skin. With the gauge valve open, pump the handle slowly and note the pressure at which the injector sprays or brakes. The correct braking pressure should be accompanied by a cone-shaped atomized spray from the nozzle. The pressures for both used and new injectors are shown in the manual. A final test of the injector should be made by slowly pressing the lever down to maintain a pressure of about 110 bar for 10 seconds. During this time, there should be no traces of fuel leakage from the nozzle. If fuel leakage or an incorrect braking pressure is detected, then the injector will require attention. While it is possible to adjust the injector pressure by changing shims, it may be more cost-effective if you're in any doubt about its overall condition to install an exchange unit. To improve visibility, we're working on a Passat engine mounted on an engine stand. The toothed belt which drives the camshaft, fuel pump, oil pump and brake vacuum pump should be free of cracks, oil and visible damage. By the way, if the belt is to be reused, make sure its direction of rotation is marked before it's removed. This enables you to refit it in the same direction, so avoiding excessive belt noise and wear. Set the crankshaft to TDC on number 1 cylinder. If the engine is out of the vehicle, as it is in our example, a special tool is required to determine the TDC position. The reference point for setting the gauge is the mark on the left of the vernier scale. Set the gauge to the value quoted in the repair manual for the particular engine and fit the tool. Recheck the setting and turn the crankshaft to align the TDC mark. Note that the TDC mark on some of the transporter engines is located on the clutch assembly. Next, fit the setting bar into the rear of the camshaft. To ensure the camshaft is set exactly, turn the camshaft until one end of the setting bar touches the cylinder head and measure the clearance. Halve the value and insert a feeler blade of that thickness between the bar and cylinder head. Turn the camshaft back slightly until the bar rests on the feeler blade, and insert a second feeler of the same thickness at the opposite end of the bar. Next, slacken the camshaft gear bolt and loosen the gear from its taper by striking it with a hammer and punch. Incidentally, the gear is secured to the shaft only by a taper. There isn't a key. This enables the gear to rotate on the shaft when tensioning the belt to achieve exact valve timing. Slacken the tensioner and remove the belt. As the Bosch type of injector pump is the most commonly fitted, we will demonstrate the procedures using this particular pump. However, a few earlier engines were fitted with a CAV pump, so for details specific to the CAV pump, consult the relevant engine manual. Before fitting the belt, align the injector pump gear by positioning the notch uppermost and inserting this locking pin. And recheck that the crankshaft is set to TDC. Fit the belt and remove the pin from the injector pump gear. Tighten the belt by turning the tensioner clockwise until the correct value is recorded on the VW210. And make sure the crankshaft does not move while tensioning the belt. As you probably remember, the VW210 scale is read in a similar way to a micrometer. Tighten the camshaft gear bolt and remove the setting bar. To settle the belt, turn the crankshaft 2 revolutions and strike the belt with a rubber hammer. Recheck and, if necessary, readjust the tension. After adjusting the belt, it's important that the point of injection, or injection timing as it's more often known, is checked. To avoid incorrect readings being recorded, make sure the cold start lever is pushed fully in. Set the engine to TDC on number 1 cylinder. And remove the plug from the rear of the injector pump. By the way, always fit a new copper washer before refitting the plug. Install the 2066 adapter extension pin and dial gauge. Preload the gauge to about 2.5 millimeters. Turn the crankshaft slowly anti- or counterclockwise until the dial gauge needle stops moving. Reset the gauge to a 1 millimeter preload and zero the dial. Now slowly turn the crankshaft clockwise until the TDC marks are once again aligned. At this point, the dial gauge reading should correspond to the value specified in the literature. Note that 2 values are quoted. The test value is the tolerance that is allowed when checking the injection timing, while the setting value is the figure to which it should be set if it requires adjustment. If the timing requires adjustment, first slacken the injector pipes and the pump mounting bolts. Rotate the pump until the correct dial gauge reading is recorded and retighten the bolts and pipes. By the way, providing there is sufficient room, this special tool makes it considerably easier to move the pump. As accurate timing is essential, rotate the engine 2 further complete turns and recheck the timing once again. On completion, don't forget to check and, if necessary, adjust the idle and maximum engine speeds, details of which you will find later in the program. On many models, if a dynamic timing figure is quoted in the emission and idling data book, an alternative method of checking the point of injection is possible. This electronic equipment provides a quick and accurate method of checking the setting. First, connect the main supply leads to the battery and fit the reference sender into the gearbox bell housing. The transducer, which picks up pulses from the injector pipe, should be fitted to cylinder number 1 or 4. Make sure the pipe is clean by polishing it with fine emery paper and a cloth. Secure the transducer as near to the pump as possible. Don't rotate or slide the transducer, as this will damage the delicate sensor. The black clamp should be connected to the injector pipe. Make sure the engine is at operating temperature and all the prerequisites described in the data book have been met. Start the engine and allow it to idle for about a minute. The injection timing, displayed in degrees, and the RPM figures can now be checked against the specifications. The idle speed affects the dynamic timing, so if necessary, correct the idle RPM before checking the timing. Corrections to the timing are, as usual, made by moving the pump. For vehicles that are not fitted with a flywheel sensor, a timing light is provided. The light is switched on by pressing the lower button, while operating the upper switch will appear to move the timing marks relative to one another. Press the switch in either direction until the reference mark and the TDC mark are aligned. The actual dynamic timing figure is displayed in the window and can be compared with the specifications. For a more detailed explanation, consult the literature provided with the equipment. Due to the high compression ratio of the diesel engine, the running clearance between the pistons and cylinder head is very small. To ensure this clearance is accurately achieved, several different thicknesses of head gaskets are used in production. Their thickness is identified by a series of notches in this area of the gasket. The part number of the gasket can also be found here. If when carrying out a repair you are simply replacing the head gasket, then one with the same number of notches should be refitted. However, if you suspect that an incorrect gasket may have been fitted at some time, or the cylinder block, pistons or crankshaft have been replaced, it will be necessary to measure the piston projection to identify the correct gasket. Firstly, turn the engine to TDC. Position a small surface plate, which is slightly higher than the piston, onto the cylinder block. Mount a suitable dial gauge and holder on top of the piston and preload the gauge to about 3 millimeters. Don't forget to zero the dial. By carefully sliding the gauge until the dial gauge pin drops onto the cylinder block, the piston projection can be measured. Check the reading a couple of times to ensure accuracy. Repeat the procedure for all 4 pistons and note the values. If different values are recorded for each piston, then use the highest reading. Compare the projection value with the chart in the repair manual to identify which gasket should be selected. The correct selection is most important, as fitting the wrong gasket can result in excessive exhaust smoke, poor starting, or even the possibility of the pistons hitting the valves. Due to the small clearance between the head surface and the valves, it's not possible to reface the cylinder head. Before refitting the head, turn the camshaft until the lobes of number 1 cylinder are uppermost. And turn the crankshaft until none of the pistons are at TDC. This prevents the pistons coming into contact with the valves when tightening the head down. To ease the alignment of the head and gasket, these special guide pins are available. Incidentally, cylinder head bolts of the multi-spline or polygon type should always be renewed. These bolts are first tightened down in stages to a torque figure and are then tightened a further 180 degrees. Once the engine has been warmed up, the bolts should be tightened a further 90 degrees. A short time after the repair, some engines require the bolts to be tightened another 90 degrees. But check the exact procedure and mileage interval with the latest literature, as this is not always the case. Older engines fitted with Allen-type bolts require a different tightening procedure, so check with the repair manual. Another advantage of the diesel engine is its low maintenance requirements. Other than the routine replacement of the engine oil and the various filters, there's very little else required. One point to note is, when draining the fuel filter of any water, first open the bleed screw, followed by the drain screw. When you're satisfied that any water has been drained, fully tighten both screws. The filter should be replaced at the recommended mileage interval. Engines built before about 1986 are not fitted with hydraulic tappets. Therefore, their valve clearances will need to be checked and adjusted periodically. They are checked and adjusted in exactly the same way as those of the petrol engines. But unlike the petrol engines, you must turn the crankshaft a further quarter of a turn from TDC before attempting to depress the buckets. This makes sure that the valve does not hit the piston when it is depressed. The cooling system does not require any special attention. However, to protect the engine from corrosion and possible overheating, the system must be filled with the correct quantity of the recommended coolant all the year round. Check that the cold start lever is pushed in. The engine is at operating temperature, and all electrical consumers are switched off. The location of the adjustment screws is, as you would expect, dependent upon the particular engine and pump type. So, as an example, we will look at two versions. On this particular engine, there are only two screws to be concerned with. This one adjusts the idle speed, and this one limits the maximum engine RPM without load. Start by setting the idle speed. And then briefly hold the throttle fully open to note the maximum revs. If they are incorrect, adjust the screw and repeat the test. On pumps equipped with idling speed boost, there are a number of adjustment screws. The idle speed is regulated by turning this screw. And the maximum RPM is set by this screw. If it is not possible, by turning the idle screw, to reduce the speed, then you will have to reset the minimum idle speed stop screw. Slacken off the lock nut and back off the screw until there is a gap. Now reset the idle speed using the normal adjuster. Readjust the stop screw by turning the screw until it just contacts the linkage, and tighten the lock nut. The adjacent screw adjusts the idle speed boost when the cold start lever is pulled out. Refer to the repair manual for more information. Finally, this screw, known as the residual volume screw, is set at the factory and should not be tampered with. If, despite this, the screw has been moved, it can cause flat spots, poor performance, or an excessively high idle speed. If you suspect that the screw may have been moved, consult the manual. The diesel injector pump is a highly accurate and expensive component, and under normal conditions, it should require very little attention throughout its life. Therefore, when diagnosing engine faults, it should always be the last component that you consider exchanging. To test, repair and adjust the pump requires sophisticated and expensive equipment operated in a scrupulously clean environment. So, major pump repairs by the VAG dealer are not possible. However, on some models, minor repairs such as replacing a leaking seal or throttle lever bush can be undertaken, providing adequate care is taken. Details of the repairs possible are described in the relevant repair manual, but as an example, here is the basic procedure for replacing a throttle lever bush on an older Golf engine. Mark the position of the throttle lever in relation to the shaft. And take off the spring and lever assembly. Mark the volume adjustment screw in relation to the pump body. And remove the screw. The exact position of this screw is very important, as a slight maladjustment will cause either excessive black smoke or lack of performance. Remove the cover retaining screws and lift up the cover while holding the spindle down. Press out the old throttle bush and coat the outside of the new one with D6 locking fluid before installing it. As several sizes of bushes are available, compare the new one with the old. After fitting the bush, wipe off any excess D6. Reassemble the components using new seals, gasket and copper washers, and set the volume screw to its original position. The same care must be taken when refitting the throttle lever, as installing the lever incorrectly by one spline will cause the engine to either idle at about 4,000 RPM or stall. Finally, recheck both the idle and maximum engine speed settings. The exact setting of the volume screw should be checked by carrying out a smoke opacity test. The test, using the VAG 1500 combustion tester, assesses the soot concentration in the exhaust emissions. Although this equipment is, at the moment, more frequently used on the continent, it will probably become more common here as future legislation is introduced. The combustion tester measures the opacity of the smoke as the engine is revved 5 times. If the value is not within the tolerance quoted in the fault-finding manual, then a slight adjustment of the volume screw can be made. But remember, this should only be considered after all the basics have been checked, such as the air filter element, compressions, injectors, and timing, etc. So, we hope that by now you're a little more familiar with the various techniques and repair procedures that are required when working on the Volkswagen Audi range of indirect injection diesel engines. In the next program of this series, we look at the turbocharged versions of these engines and the 5- and 6-cylinder models. We also examine the repair aspects of the 2.4-litre Volkswagen Taro diesel.